Hi, I'm Patrick Reagan. Welcome to the Wireless Networking, Part 2, Frequencies, Channels, and Wireless 802.11 Standards. During this video, we have covered licensed and unlicensed wireless spectrum, frequencies used in 802.11 standards, Wi-Fi channels, band steering, and the various 802.11 standards from the 802.11a and b through the 802.11be, also known as Wi-Fi 7. When using wireless, you can use licensed or unlicensed. Government agencies control how the electromagnetic spectrum is used and license certain frequency bands for specific activities. Countries apply their own regulations to allowable channels, allowed users, and maximum power levels within these frequency ranges. Most of the radio spectrum is licensed, such as television and radio broadcast. Individual companies pay a licensing fee for the exclusive use to transmit on an assigned frequency within a certain geographical area. In exchange, those users can be assured that nothing will interfere with their transmission. Licensed and unlicensed spectrum devices will have limits on transmitting power to reduce interfering with others on the same frequencies. Wireless regulations are complex, and you need to refer to the country's regulatory agency. In the United States, popular frequency bands the FCC has assigned for unlicensed use are 2.4 GHz, 5.0 GHz, and 6.0 GHz. Use of these bands does not require filing with the FCC. The 2.4 GHz band is slower, but can reach further than the 5 and 6 GHz signals. The 2.4 GHz can also penetrate walls better than the higher frequencies. Lower frequencies have lower wavelengths, which allows it to bend around objects because of the diffraction compared to higher frequencies. The 5 GHz band is faster and does not penetrate objects like walls or doors as well as the 2.4 GHz. The newest wireless devices can use 6 GHz. If you're in the same room as your router and your machine has direct line of sight, 5 GHz and 6 GHz will most likely give you the best performance unless you have interference. As you can see in the table, the 2.4 GHz has longer range than the 5 and 6 GHz frequency bands, as well as better wall penetration, but 5 and 6 GHz offer higher speeds. Each range is divided into a multitude of channels. The 2.4 and 5 GHz Wi-Fi signal range comprises smaller bands or channels. For 2.4 GHz in the United States, any Wi-Fi channels 1 through 11 can be chosen when setting up a wireless LAN. There are overlapping of channels. Channels 1, 6, and 11 are distinct channels that don't overlap with each other. Europe, Asia, and other regions support channel 12 and 13, and Japan also supports channel 14. These are not allowed for general use in the US under FCC regulations. For 5 GHz, there are 25 channels with no overlapping. The 6 GHz band can provide a large number of channels, up to 233 channels. Not all channels will be available in every country. A wireless access point can automatically move devices to unused channels by using a feature called Auto Channel Selection or Dynamic Channel Selection, or DCS, which scans the network for the least congested channel and switches to it when significant interference is detected on the current channel, effectively moving connected devices to a less crowded frequency band. The access point periodically scans nearby channels to assess the level of interference. When interference reaches a certain threshold, the AP will switch to a less congested channel. When the channel changes, the connected devices will be notified and automatically transition to the new channel, potentially experiencing a brief moment of disconnection. As a result, there will be improved signal strength and devices can experience better connection quality and reduced lag. In addition, distributing devices across different channels helps to alleviate network traffic issues, resulting in reduced network congestion. Note, switching channels may cause brief connection drops while devices reconnect. Using a Wi-Fi analyzer can help identify the best channels in your environment before enabling auto channel selection. Band steering is a technology that automatically directs devices capable of connecting to both 2.4 GHz and 5 GHz Wi-Fi bands to the faster 5 GHz band when possible, reducing the congestion on the slower 2.4 GHz band and improving overall network performance for compatible devices. Essentially, it helps manage which frequency band a device connects to based on its capability in the current network conditions. Obviously, this feature is only available on routers that support both 2.4 GHz and 5 GHz bands. While beneficial for most modern devices, band steering may not be effective if a network has a large number of older devices that only supports the 2.4 GHz band. The 802.11 standard is a set of specifications created by the Institute of Electrical and Electronics Engineers that define how wireless local area networks operate. The purpose of the 802.11 standard is to define the protocols and standards for wireless networking communications in local networks. Frequency bands typically include the 2.4 GHz and 5 GHz, with newer standards also supporting 6 GHz. Each version improves speed, efficiency, range, and other features. Note, to use the fastest speeds and features, both the AP and the client will have to support the appropriate 802.11 version associated with the speeds and features. If you upgrade your AP to Wi-Fi 7, to get the speeds and features with Wi-Fi 7, you will have to make sure that the clients are also capable of using Wi-Fi 7. 802.11a was the original standard that operated at 5 GHz up to 54 megabits per second. The 802.11b operates at 2.4 GHz and 11 megabits per second. While it has a better range, there are conflicts with other wireless devices including cordless phones, microwaves, and Bluetooth. 802.11g operates at the 2.4 GHz range and is backward compatible with the 802.11b. 802.11n, or Wi-Fi 4, operates at 5 GHz and/or 2.4 GHz with 40 MHz channel widths. It introduced multiple input, multiple output, also known as MIMO, with multiple transmit and receive antennas and up to 600 megabits throughput. By having multiple antennas, more data can be transmitted simultaneously, increasing network throughput. While a single user MIMO can transmit multiple streams to only one device at a time, multi-user MIMO can send multiple streams of data to multiple devices simultaneously. It is designed to be backward compatible with the 802.11a, b, and g. 802.11ac, or Wi-Fi 5, operates at 5 GHz band and uses more frequencies up to 160 MHz channel bandwidth. It has 8 MIMO download streams and up to 6.9 gigabits per second throughput. While 802.11ac only specifies 5 GHz bands, some access points will also support the 802.11n standard, which provides connectivity for 2.4 GHz devices. It is backward compatible with the 802.11n, but only at 5 GHz. The 802.11ax, or Wi-Fi 6, operates at 6 GHz, 5 GHz, and 2.4 GHz. 1,201 megabits per channel, 8 bidirectional multi-user MIMO streams, and up to 9.6 gigabits per second throughput. It supports orthogonal frequency division multiple access, which is a wireless communication technology that allows multiple devices to transmit data simultaneously over a shared frequency band. It supports most backward compatibility devices including A, B, G, N, and AC. 802.11be, or Wi-Fi 7, operates at 6 GHz, 5 GHz, and 2.4 GHz, 1,201 megabits per channel, and 16 bidirectional multi-user MIMO streams, and up to 46 gigabits per second throughput. Multi-link operation, or MILO, is a feature that increases capacity by simultaneously sending and receiving data across different frequency bands and channels. It is backward compatible with all previous Wi-Fi standards. Here's a table of all the Wi-Fi standards. As you can see that each version has increased throughput. 802.11n and newer can support channel bonding. Channel bonding creates more room for data by bonding or combining two or more 20 MHz channels into a single 40, 80, or 160 MHz channel. Channel bonding increases data rate because data rate is directly proportional to channel bandwidth. By doing channel bonding, the number of available channels decrease. Increasing data throughput through Wi-Fi channel bonding can cause more interference, especially in crowded environments. More interference occurs because wide channel overlaps with more neighboring networks, especially in the 2.4 GHz band. The best practice for 2.4 GHz is to avoid bonding beyond the 20 MHz because interference is very likely. For 5 GHz and 6 GHz, bond to 40, 80, and 160 MHz only if you're in a low interference environment and need the speed. 802.11h is intended to resolve interference issues introduced by the use of 802.11a in some locations, particularly with military radar systems, satellite, and medical devices. It essentially helps wireless local area networks share spectrum with other devices, including radar and satellite systems. It includes dynamic frequency selection, or DFS, which automatically switches the network to a different channel when it detects other devices like radar or medical devices, which helps reduce interference and data loss. Transmit power control, or TPC, limits the radio frequency output power of each network transmitter, which helps reduce interference and power consumption. It enables 802.11 devices to listen before transmitting so that they can adjust their power and change channels as required, and it allows wireless clients to move to a new channel used by the access point by notifying the wireless clients about the change of channel, which minimizes data loss when the radio moves to the new channel. Question: which frequencies offers the most channels? Answer: 6 GHz. Question: you need to install wireless LAN in an auditorium. You need to use multi-user MIMO to improve connection performance in higher density areas. You also need to support both 2.4 and 5.0 GHz devices. Which would you recommend? Answer: 802.11ax. Question: the company currently uses 802.11 wireless standard on all access points. You are upgrading the wireless infrastructure for a company. You want to upgrade to be backward compatible and be the least expensive. What would you recommend? Answer: 802.11n. Question: what is the maximum speed for 802.11b standard? Answer: 11 megabits per second. Question: which wireless technology can you use at home that would give you the compatibility with the widest range of devices possible? Answer: 802.11n. Question: Which provides the best performance while supporting devices running at 2.4 GHz and 5.0 GHz devices? Answer: 802.11n. Question: what old standard supports old wireless devices that only operates at 2.4 GHz frequency? Answer: 802.11b. Question: which of the answers listed below refer to an amendment to the IEEE 802.11 standard which introduced address spectrum and power management issues in wireless networks? Answer: 802.11h. Question: which of the following frequency bands are supported by Wi-Fi 6 compatible devices? Answer: all of the above. Question: you want to implement a technology that will allow user devices to automatically navigate to the best available frequency standard. Which of the following technologies should you use? Answer: band steering. Question: following the implementation of a BYOD policy, some users in a high density environment report slowness over a wireless connection. Some wireless controller reports indicates high latency and airtime contention. Which of the following is the most probable root cause? Answer: the AP is configured with 2.4 GHz frequency without band steering capabilities. Question: after upgrading to a SOHO router that supports Wi-Fi 7, the user determines throughput has not increased. Which of the following is the most likely cause of the issue? Answer: the user's workstation does not support 802.11ax. Question: a wireless network technician is receiving reports from some users who are unable to see both of the corporate SSIDs on their mobile devices. A site survey was recently commissioned and the results verified acceptable RSSI from both APs in all user areas. The AP supports modern wireless standards and all broadcasting their SIDs. The table shows the two APs, one running 802.11b and the other running 802.11a. Which of the following changes will result in all of the user devices being capable of seeing both corporate SSIDs? Answer: configuring both APs to use the 802.11ac wireless standard. Question: a small office is running Wi-Fi 4 APs and neighboring offices do not want to increase the throughput to associated devices. Which of the following is the most cost-effective way for the office to increase network performance? Answer: enable channel bonding. Question: which of the following answers refer to the 2.4 GHz frequency range when compared to higher frequency bands like 5 and 6 GHz? Select three answers. Answers: the longest range and better penetration through obstacles, higher susceptible to interference due to device congestion, and the lowest number of non-overlapping channels. Question: which of the answers listed below does not refer to the 6 GHz frequency band? Answer: the longest range among available Wi-Fi bands. Question: which of the following best describes the effect of increasing channel width in a wireless network? Answer: increases data throughput but may cause more interference. Question: in the 2.4 GHz Wi-Fi, which channels are not overlapping? Answer: 1, 6, and 11. Question: what are the characteristic features of the IEEE 802.11b standard? Choose all that apply. Answer: 2.4 GHz frequency band and maximum speed 11 megabits per second. For more information, visit these sites. In summary, when using wireless, you can use licensed or unlicensed frequencies. Popular frequency bands the FCC has assigned for unlicensed use are 2.4 GHz, 5.0 GHz, and 6.0 GHz. For 2.4 GHz in the United States, any Wi-Fi channels 1 through 11 can be chosen when setting up a wireless LAN, of which channels 1, 6, and 11 are distinct channels that don't overlap with each other. A wireless access point can automatically move devices to unused channels by using a feature called auto channel selection or dynamic channel selection, which scans the network for the least congested channel and switches to it when significant interference is detected on the current channel, effectively moving connected devices to a less crowded frequency band. Band steering is a technology that automatically detects devices capable of connecting to both 2.4 GHz and 5 GHz Wi-Fi bands to the faster 5 GHz band when possible, reducing congestion on the slower 2.4 GHz band and improving overall network performance for compatible devices. The 802.11 standard is a set of specifications created by the Institute of Electrical Electronics Engineers that defines how wireless local area networks operate. To use the fastest speeds and features, both the AP and the client will have to support the appropriate 802.11 version associated with the speeds and features. Channel bonding creates more room for data by bonding or combining two or more 20 MHz channels into a single 40, 80, or 160 MHz channel. Thank you for watching this video. The next video will be wireless networking, part 3, configuring wireless and wireless security. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.